Let us start today module 1, the fundamentals of electrical engineering. So what all will discuss for this class, we'll see one by one. So first, as a topic, we are discussing on sources of energy. We have different sources of energy. It's divided into two types. One is conventional sources, other one is non-conventional sources. Again, under conventional sources, we have two types. One is commercial, other one is non-commercial. So under commercial, we speak about coal, petroleum, electricity, so on. And under non-commercial, we speak about firewood, straw, dry dung. So coming back to non-conventional sources, we have bioenergy, solar energy, wind energy, tidal energy, energy from urban waste, so on. So coming to this conventional energy sources, under conventional, we will discuss what is conventional energy sources and what are the advantages and disadvantages of conventional sources of energy. Similarly, we speak about non-conventional sources of energy. What is that? And then what are the advantages and disadvantages of non-conventional sources of energy? So let us start with the conventional sources. We have conventional energy sources like the energy sources that are present for a long time, which are found naturally beneath the earth and take a long time to produce or replenish are known as conventional sources of energy. Generally, these are also non-renewable energy sources. The fossil fuels like plants and animals remains which have been buried from millions of years ago within the earth. These remains are decomposed and formed primary energy sources like coal, petroleum, natural gas, etc. So what are non-conventional energy sources then? The natural resources that can produce useful energy continuously for a long period of time and are available again and again for use even after it is exhausted are known as non-conventional sources of energy, and it is also called as renewable sources of energy. Some types of non-conventional sources of energy are sunlight, wind, water flow, and ocean. So let us discuss the advantages of conventional sources of energy. The efficiency of this energy source is very high. The production expenses are low. The raw materials of conventional sources of energy are easy to transport. Raw materials such as coal, petroleum, natural gas can be transported easily through trains or ships from one place to another. Generally, it doesn't need any specific place for installation. The government can easily set up a conventional plant according to their requirements. So less land area is required for power plant installation. Now we have discussed advantages of conventional sources of energy. So let us move on to the disadvantages of conventional sources of energy. There are few disadvantages. To list few, the fuels are likely to be depleted soon, forcing us to conserve them and find alternative resources. Toxic, hazardous fumes and residues pollute the environment. Overall conversion efficiency is very poor. Production cost is also high. Similarly, we have certain advantages of non-conventional sources of energy. To list few, available in abundant, it has low carbon emission and hence it's environmental friendly. Production cost is low. Renewable energy resources are pollution free and freely available. So what are the disadvantages of non-conventional sources of energy? The efficiency of the energy sources is low and the initial investment. So initial investment cost is high. Large land area is required for the installation of a power plant. Inconsistent and unreliable supply. So after knowing the advantages and disadvantages of conventional and unconventional sources of energy, if it is put together, how do you compare the conventional with non-conventional? So let us compare and see the sources of energy. Coming to conventional sources of energy, these are already available in nature but cannot be used after they are exhausted. Similarly, for non-conventional sources of energy, these are also already available in nature but can produce energy continuously at an almost constant rate. So, what is the next difference between conventional and non-conventional? The second one is they are limited in nature, which are conventional sources of energy are limited in nature, whereas non-conventional sources of energy are continuously replenishing energy resources and will be exhausted after millions of years. Therefore, we can extract an unlimited amount of energy from them. So the next difference is coming to conventional. It produces a lot of pollution, which is harmful to both humans and nature. So similarly for non-conventional, byproducts are very less or negligible. Hence, these are good resources of energy. So coming to conventional, some energy resources are available for both domestic uses and even for industrial uses. And coming to non-conventional, these are used majorly for domestic purposes. Coming to non-conventional sources of energy, conventional type of energy, fossil fuels and nowadays nuclear fuels are some of the examples of conventional sources of energy. For the non-conventional, sunlight, ocean tides, wind, geothermal energy, and hydro energy are some of the examples of non-conventional sources of energy. After knowing the differences between conventional and non-conventional, we are moving on to the next topic, the general structure of typical transmission distribution scheme or electric power system. So we have here, there is a line diagram. You know what is power system. A power system is a highly complex electrical network. So it transmits that power system which transmits electrical energy rapidly from the place where it is generated to the place where it is used. So it is basically divided into three stages. One is generation stage, other one is transmission stage, other one is distribution stage. So this electrical energy, whichever is generated at a remote place, has to be transmitted over a long distance to the load centers through transmission lines. Not only transmission line, feeders and distribution lines are also involved in this. So this is actually shown a typical transmission distribution scheme. Here it shows typical power system scheme in the form of a single line diagram. The electrical energy which is generated at 11 kV by alternators or three-phase synchronous generators. Here, this voltage level will be very, very small for the purpose of transmission of bulk power over long distances. Therefore, this voltage to be stepped up to a higher voltage for 220 kV or 220 kV or 400 kV by means of step-up transformers at the generating station itself. Now, this electrical energy at these high voltages is supplied to a receiving station. There, actually, which is far away from that receiving station will be very far away from the generating station. So, at the receiving station, the high voltage is stepped down to here at the receiving station. It will be stepped down to 66 kV or 33 kV. The transmission of electrical energy from generating station to receiving station at 220 kV or 400 kV. This is known as primary transmission. The electrical energy at 33 kV or 66 kV is transmitted to substation which are located very near to the load center. This is known as secondary transmission. So at the substation, This 33 kV is stepped down. So here it is stepped down to either 6.6 kV or 11 kV. So large industrial consumers are supplied at 66.6 kV or 11 kV from the substation itself. So to supply electrical energy for domestic consumption by small consumers, it is transmitted at 6.6 kV or 11 kV to distribution transformers. This is known as, actually, this stage is known as primary distribution. The distribution transformers are located in commercial and residential areas, and they step down the voltage from this 6.6 kV to 400 volts or 230 volts single phase. The transformer, this transfer of electrical energy from distribution transformers to domestic consumers is known as secondary distribution. Now, the power supply scheme now we are seeing here is a comprehensive one, and it's not necessary that every power system network should have all the stages. So in particular network, there may not be any secondary transmission or any primary distribution. Sometimes a particular network may just have the secondary distribution at all. See here, this is actually the secondary distribution where it is finally reaching the consumers. So this is about the general structure of typical T&D scheme, and it's very, very important to know. So this completes the first class. Thanks for watching. For more videos, you can subscribe to our YouTube channel, and our YouTube channel is this. Thank you.